This lesson is on multi-digit multiplication using the area model. So back traditionally, we have what's called the standard algorithm. That looks something like this, where you would multiply and then you would carry. And now in fourth grade, they're trying to understand more of the why behind the math that they're doing than just how to get the answer. So with the area model, what the area model does is it's actually going to use the distributive property to first break apart the number 24 into expanded form. So 24 in expanded form is 20 plus 4. Then they're going to use a model called the area model, which taps into area that they learned in third grade and array models that they learned in third grade. And so you're going to use the box to represent the area of something, and you're going to use this as a model to help organize the multiplication that you're doing. So our rectangle, we're going to set up our rectangle so that it has 2 columns because we have 2 values that we're going to multiply, 20 and 4. It's only going to have 1 row because we're only multiplying by a 1-digit number, so we're going to put 7 on the side. So now that we have our distributive area model set up, now we can use this model to multiply. So in this first box, you're going to want to multiply what's beside the box, 7, with what's on top of the box, 20. For this column right here, you're going to multiply what's beside the box, 7, times what's on top of the box, 4. So the distributive property says that you can break a number apart to multiply it and then add it at the end to put it back together. So we're going to multiply our parts. 7 times 2 is 14, and we add on 1 0. So 7 times 20 is 140. For this column, 7 times 4 is 28, and we're not tacking on any zeros because we don't have any zeros to move. So we've multiplied our parts, and now we're going to add it to put it back together. 140 plus 28 gets me that same 168. So the area model is always going to get you the same answer, but this explains more clearly that you're multiplying 20 times 7 instead of 2 times 7 over here. So this helps support the why behind what you were doing. So let's do another example for the area model. So this time for the area model, we're going to have a 3-digit number. 354 times 6. So step 1, write it in expanded form, the biggest number. We're going to take it over to the side and we're going to write 354 in expanded form. 300 plus 50 plus 4. Step 2, draw your model. So we're going to draw our rectangle, and this time we need 1, 2, 3 columns because our number has 3 digits or 3 values. Above the first column, we're going to put 300. Above the second column, we're going to put 50. Above the third column, we're going to put 4. And we're multiplying each of these values by 6. So it's only going to have 1 row because our bottom factor only has 1 digit. Step 3, multiply. So we're always going to multiply for each column what's beside the box and what's on top of the box. So we're going to multiply what's beside the box, 6, times what's on top of the box, 300. For this column, what's beside the box, 6, times what's on top of the box, 50. For this last column, what's beside the box, 6, times what's on top of the box, 4. And now to make the multiplication simpler and to try to train kids for mental math, we're going to multiply 6 times 3, which is 18, and then move those 2 hundreds, zeros down, 1,800. 6 times 5 is 30, and move your tens 0 down. 6 times 4 is 24. So the distributive property says we can break it apart to multiply it, which we've done. And now we're going to add it to put it back together. So we're going to take each one of our partial products and write them from greatest to least so that we line them up correctly, and just add them up to get our final product. 0 plus 4 is 4, 2 plus 0 is 2, 8 and 3 is 11, 1 and 1 is 2, 2,124. So I hope that this helps with the area model for 2 and 3 digit by 1 digit numbers. There's also an area model for 2 and 3 digit numbers by 2 digit numbers, but that's on a separate page. So now from here, I highly suggest that you watch the partial products video, which is a slightly different method for solving the same problem.